Time for a new chapter. We're talking about circles in this unit. We're going to start off with some vocab. There's circumference, an area that we should know already, but if you don't, that's okay. So what is a circle? It's probably hard to define for you, but it is a collection of all points equidistant or the same distance away from a fixed point. That fixed point, of course, is going to be our center. And of course, that distance that they are away from the center, that's our radius. So, some more vocab, some you probably have seen, probably most of it. The radius is a line segment from the circle to the center of a circle. So it says draw AB, so that can go anywhere on the circle, and we label that point B. That's a radius. The diameter is a segment that has endpoints, because it is a segment, so their endpoints are on the circle and goes through the center of the circle. And again, we know what this is. Don't let the definition confuse you. It's just the distance right across the circle going through the middle. Whoop, draw diameter CD. So let's put CD right there. Our endpoints are on the circle. It goes through the center. A chord is a line segment whose, well, it's the same thing, has endpoints are on the circle. So the only difference here is it doesn't have to go, or really it can't, well, a specific version of a chord is a diameter, but any chord is just where we have endpoints on the circle. So it says EF, so let's see, E and F, just 2 points on the circle, connect them, that's a chord. CD is also a chord, but more specifically, it's a diameter. Our secant, it's a line that intersects the circle in 2 points. Draw secant BE above. So all we have to do is connect B and E. Notice that we do intersect the circle twice. That is a line. And that's it. That's our secant line. It goes through the circle once and it comes back out. As opposed to a tangent, which intersects a circle at only 1 point. That point is called the point of tangency. So draw point G outside of circle A. So I don't know, circle, or there's point G. And then it says, draw point G outside the circle, then draw a tangent from point G so that point F is the point of tangency. So that means when we make this, hopefully your diagrams are a little bit better, but we kind of just run through F and it doesn't touch the circle anywhere else. That is our tangent line. So those are the vocab that we're going to be dealing with. Let's try and match them up. Our segment AC, it's a chord, but it's also the diameter. AE, we can kind of tell that's a line symbol over top. So AE as a line is a secant, because it goes through the circle in 2 places, A and G. Now, BA, whoops, now I'm looking at this. Letter A isn't diameter, it's radius. BA is the diameter. Sorry about the confusion. AG, segment AG, is just a chord. When it's a line, it's a secant. When it's a segment, it's a chord. DE, line DE, that is a tangent, because it only touches the circle once at B, and that point B is our point of tangency, meaning where that line touches the circle once. So just vocab, nothing too crazy. Let's roll on to the back. Use a diagram to find the given lengths. The radius of A. So that would be here, and just count how many boxes since it's completely horizontal. It's just 1, 2, 3. So the radius is 3. Diameter of B, we do the same thing. Well, that's 2. Whoop. That's the radius is 2, but they want the diameter, so it's another 2. So grand total of 4. The diameter of C, so we want all the way here to here, because it does overlap. You look at the green circle, you can see that that's the diameter. So it's 1, 2, 3, 4, 5, 6 for the diameter. Now the radius of D, I'm going to have it going this way just so we can see it different. Well, that's 2. And what are the coordinates of B here? 1, 2, 3, 4, 5, 6, 7, 8. And it's up 3. So our point is 8, 3. So just a little bit of work with the radius and what they are and the diameter, and well, we're going to see how they're related in a second. So to find the circumference of a circle, there's 2 different formulas. 2 times pi times r, a radius length, or just pi times our diameter. That's for our circumference. The area of a circle is pi r squared, and there's only one formula for that. So if we forget about the pi d for a second, circumference and area both have the same numbers. They'll both have a 2, a pi, and an r. The difference is that the radius is squared in the area of a circle, and area is square units. So that's why we know that 2 is going to be the exponent and not the coefficient like it is in circumference. Relationship between radius and diameter, well, 2 times the radius equals the diameter. Or I suppose if you went the opposite direction, the diameter is 1/2. Oops, no, 1/2 the diameter is equal to the radius. Obviously it's the same thing, just kind of written the opposite direction. All right, now using circumference and area of a circle formulas, we're going to find the circumference and area of each circle, both in terms of pi. That is our exact answer, meaning we didn't round, that is the full value. But we're also going to be approximated to the nearest hundredth, because we'll have to round, it's not exact. So before we do anything, we need to figure out what our radius is. And in this case, in number 1, it's just 5.3. So for circumference, I'll just leave it at C. Oops. It is 2 times r, well, let me write this out. 2 times pi times r. And so we're not simplified yet. We got to do the 2 times the 5.3. So 10.6 pi miles, or that's approximately 33.30 miles. So this is the exact answer. That's an approximation because we rounded. For area, we got pi r squared. If we just square the 5.3, we get 28.09 pi miles squared. And we throw 28.09 times pi in the calculator, we get approximately 88.25 miles squared. And that's our area, and that's our circumference. And you need to make sure you have units and the proper units. Miles for circumference, miles squared for the area. All right, we got one more left to do. I don't know why I feel like switching colors, but I do. So we need to find our radius. Diameter will work, but the radius is what we need for the area. So we just cut our diameter in half, and that's our radius. So for the circumference, we can actually use pi d, which is our diameter, and that way we don't even have to multiply anything out for our exact value. So it's 12.4 pi inches, which is approximately 38.96 inches. So we can just use the diameter there. We could have done 2 pi r. 2 times 6.2 is the 12.4. Now the area, remember, is pi r squared, so we had to have the radius. Even though we could have just used the diameter for circumference, area, you need the radius. So if we were to square the 6.2, this is our exact value. But if we approximate it, it's 120.76 inches squared. Make sure that you keep the right units and if they're squared or not.